Hey everyone, welcome back to the channel. Today we are going to explore a cool technique for training model in TensorFlow, that is exponential learning rate scheduling. I will walk you through what it is, how it works, and of course show you the implementation it with some code. So let's dive right in. So first thing first, what is exponential scheduling? So it is a method where we gradually reduce the learning rate during the training to allow the model to converge more smoothly at its approach to solution. Essentially, we start with a large learning rate to make faster progress and then decreases exponentially over time to fine tune the model. So in TensorFlow, we achieve this by using the exponential decay function. So this function which updates the learning rate after every step, after every training step based on this formula, right? Where the LR function t is the learning rate at a time step t, LR0 is the initial learning rate. Then we have a decay rate, is the rate at which the learning rate decay. Decay step is how frequently we apply the decay. Now let's, while these libraries are loading, so exponential learning rates scheduling is beneficial because it allows faster convergence in the early stage of training, and it's fine-tune the model as training progress, and it helps to avoid overshooting the optimal solution. And also helps with SGD, the stochastic gradient descent, preventing the model from getting stuck in the local minimum. So let's jump into the TensorFlow and implement exponential scheduling with exponential decay function. So I will show you how to set this up and integrate in a training process. So while our libraries are loaded, let's define our hypercad parameters. In the next, we are defining the exponential decay schedule. And these learning rate decay steps we have already defined here. And let's create the model. Next, we'll compile the model. And let's simulate the training steps. So we'll take 5,000 steps for this and calculate the learning rate. And finally, let's plot the learning rate. So this is the exponential learning rate scheduling. On the y-axis, we have the learning rate, and these are the training steps we have chosen the 5,000. So till now, we define the initial learning rate to 0.1 and set the decay to 0.96 and specify the decay steps as 1,000, meaning the learning rate will decay every 10,000 steps. As you can see, every 10,000 is decaying. So we use exponential decay function from TensorFlow, which will update the learning rate based on our parameters. We created a simple neural network model and compile it with Adams optimizer that uses our exponential decay learning rate schedule. And finally, we stimulate a training loop by computing the learning rate for each steps and plotted it. Now, uh, to better understand the impact of exponential scheduling, let's compare with the constant learning rate. So we'll plot both the learning rate schedules and visualize how the exponential decay behave over time compared to a constant value. So this is the constant learning rate which we have defined, and we are now let's plot both the learning rates together. And as you can see in the graph, the constant learning rate in red stays in the same throughput, while the exponential decay in blue start high and gradually reduce. So the exponential decay allows the optimizer to make bigger moves at the beginning of the training and smaller, more defined adjustment as it gets closer to the optimal solution. And now let's talk about the fine-tuned parameters. So initial learning rate, so it's a higher initial learning rate can help the model converge faster initially, but make sure it is not too high or you risk for overshooting. The decay rate, which we have added 0.96. So decay rate closer to 1 means the learning rate will decay more slowly, whereas a lower decay rate means faster decay, right? Experiment with different values to find the best balance for your model. And the last is the decay steps. So this controls how frequently the learning rate change. A smaller number means faster decay, while the larger number leads to a slower decay. So exponential scheduling is essentially used when training deep neural networks, where an initial high learning rate can help escape local minima, and then smaller learning rate fine-tunes the solution. So for instance, if tasks like image classification or natural language processing, you can use exponential decays to stabilize the learning rate over time. So to wrap this up, exponential learning rate scheduling is a powerful way to optimize your model training, and by starting with high learning rate and decaying over time can help your model converge more efficiently and avoid getting stuck in local minimum. So we have seen how to implement it with TensorFlow and compare the constant learning rate and talk about some tuning tips. Thank you for watching. I will see you in the next one.